far, this is now the third part of our review on Unit 5 integration. All right, so what I'm going to be doing here for pretty much all of this is going to be U substitution. All right, so this will be probably some of the more challenging problems will end up in this section, okay? So let's start with this first question, 32. So I'm going to set U equal to 1 plus sine of theta. And then if I take the derivative of that, that's du equals cosine theta d theta. Now, if you look in the problem, you'll notice that I have cosine theta times d theta, which is right here. That's the same as du. And then my denominator has the square root of 1 plus sine theta, and 1 plus sine theta is u. So watch what happens when I plug that into my integral. So I have du over the square root of u. Now, I'm not going to leave it like that, right? I'm going to write this as u to the negative 1/2 power du, right? And one thing I'm going to do to make this problem faster for myself is you'll notice the original limits of integration were 0 to pi over 2. If I take these limits of integration and plug them into my theta where it says u, I can find my new limits of integration, and I don't have to go back into the original stuff. So it'll save me time to do this. So 1 plus, I'll do right here, 1 plus the sine of pi over 2, and then 1 plus the sine of 0. Whatever I get, that's going to give me my new limits of integration. So the sine of pi over 2 is 1, so 1 plus 1 is 2. And the sine of 0 is 0, so 1 plus 0 is 1. So now if I go backwards, right, antiderivative here is going to be u to the positive 1/2 power. But when I distribute that, or I should say differentiate that, I don't want to have a 1/2 in front, so I'm going to put a 2 there. All right, so that's my antiderivative that I'm going to evaluate at 2 and 1. So I'm going to do 2 times 2 to the 1/2 power minus 2 times 1 to the 1/2 power. So that's 2 times the square root of 2 minus 2. So this is my answer. You'll notice none of the answer choices look like this, but if you were to factor out a 2, that would leave you with the square root of 2 minus 1. So it's going to be letter D. Let's go to 33. All right, 33. All right, I'm going to do the same process of u substitution. This time it actually tells me what to use for my u. So if u equals the square root of x, let me write that. Actually, you know how I'm going to write it. X to the 1/2 power. And then du is going to be the same as 1/2 x to the negative 1/2 power times dx. All right. Now, if you look in the problem, all right, we have the square root of x on the bottom, and we have dx, but I don't have a 1/2. So like we did in our notes for this, we need to do some algebra to make sure we get the right stuff in the integral for our substitution. So to get that 1/2 to go away, I'm going to multiply all of this by 2. All right, so that's going to leave me with 2 du is the same as x to the negative 1/2 power dx, which is in my problem. All right, so that's good. All right, so I'm going to do my new integral. I'm going to have new limits of integration here in a moment. That's e to the power of u. So e to the power of u, all right? And then the square root of x in the bottom, and dx is actually the same as 2 du, but you put that 2 out front, right? That constant goes in front. Now here are my new limits of integration. I'm going to plug in, right, 4 into the square root of x, and I'm going to plug in 1 into the square root of x. The square root of 4 is 2, square root of 1 is 1. So I'm looking for this to be my answer. All right, it looks like C has that for my answer. 34. All right. Another definite integral that I'm going to be using u substitution. So u is x plus 1. So du is actually 1 dx. And if you look, that's what I have. So actually, I'm ready to go with my u substitution. I'm going to have u to the 1/2 power du. Get my new limits of integration by plugging in 3 where it says x, so 3 plus 1. And 0 plus 1, remember you're plugging these into what you put here. So that's 4 and 1. The antiderivative for u to the 1/2 power is going to be u to the 3/2 power. So you put 2/3 in front to get rid of that. and I'm evaluating this at 4 and 1. So 2/3 times 4 to the 3/2 power minus 2/3 times 1 to the 3/2 power. So remember 3/2 power, you can use decimals if you want here, but that denominator in that power of 2 means the square root. So watch how I do this. This is the square root of 4, which is 2. 2 cubed makes 8. And then same thing here, square root of 1 is 1. 1 cubed is 1, so that's minus 2/3. Distribute the 8, you get 16/3 minus 2/3, which is 14/3. So 34 is D. 35. All right, now 35 is actually not a U substitution one here. This is really more at the very end of last semester, but I want to put back in here so you have some work with some trig and finding antiderivatives. Right, this is an indefinite integral. So really what I did here was I split this up into two indefinite integrals where the sine of 2x dx plus the integral of cosine of 2x dx. All right, so I'm just trying to go backwards here. All right, so if I take the derivative of cosine of 2x, that's going to give me negative sine of 2x times 2. Well, you'll notice up here in the original, there's no negative, so I have to have that in front. And there's no 2, so I need to do the reciprocal of 2, which is 1/2. So that's the first part. Second part would be, we know we have the sine of 2x to get me cosine of 2x, but you notice there's no 2 in front, right? You have to do the chain rule. Derivative of 2x is 2. So again, like before, I'm putting that 1/2 in front. So this is going to be my answer, obviously, with a plus c. So I'm looking for negative 1/2 cosine of 2x plus 1/2 sine of 2x, which is B. 36. All right, now 36 is going to be U substitution again. U is going to be x cubed minus 1, and du is going to be 3x squared dx. And if you notice, I have x squared dx, but I don't have that 3. So to move that 3 out of there to the other side, I'm going to divide everything by 3. Now watch how I write that here. So that's 1/3 du is the same as x squared dx. All right, so that takes care of the x squared dx. I've got my U substitution. We're ready to do that integral now. Remember, the 1/3 is going to go out front, and then it's going to be u to the 10th power times du. All right, no need to worry about changing limits of integration. This is an indefinite integral, so I'm just going to find the antiderivative. So I should put f of u, which is going to be u to the 11th power. But if you take the derivative of that, you get 11 times u to the 10th power. And I don't want 11. I want just 1. So do the reciprocal. All right. Now I'm going to put 1/3 in front of this. So times. And I'm going to bring back in, because you know this is indefinite, I'm going to bring back in my u. So it's going to be 1/11th times x cubed minus 1 to the 11th power. If you multiply the 1/3 and the 1/11th, you get 1/33. So I'm looking for this in my answer. And the only one that makes sense, it's written a little differently, but you have the 33 in the denominator, is going to be letter D. Okay, 37. All right. Now 37, I'll pull up the formula sheet here if you need it, but I'm going to try it without it first. Essentially, when I do this, right, I'm going to have the integral of 0 to 1 of e to the negative 4x. So the antiderivative here, right, would be e to the negative 4x power. If you remember from your days in derivatives, when you take the derivative of e to the negative 4x power, here's how you do it. You copy it down first, and then you multiply it by the derivative of the power, which is going to be negative 4. All right, but when you look in my integral, I don't have a negative 4 in front. I actually have a 1. So to get rid of that negative, I have to put a negative. And then I need to do the reciprocal, which is 1/4. So this is actually my antiderivative for this problem. I'm going to evaluate that at 1 and 0. So negative 1/4 times e to the negative 4 times 1 power minus negative 1/4 times e to the negative 4 times 0 power. That's negative 1/4 times e to the negative 4th power minus, now watch what happens here. E to the 0 power is 1, right? Anything to the 0 power is 1. So that's minus a negative 1/4. That's going to become addition. And so I'm good with this as my answer. You look in the answer choices, you might not see it, but if you kind of rearrange it and then put that e to the negative fourth power up top, you're going to see that it's going to be this one here, letter D. 38, another u substitution problem. This time u is going to be 3x squared plus 12x plus 1. So if I take the derivative of that, du is 6x plus 12 dx. Now, if you look, I don't have 6x plus 12 dx. I have x plus 2 times dx, so I need to get rid of that 6 and the 12 by dividing both sides by 6. And again, how I write that is actually as a fraction in front of du. So 1/6 du is the same as x plus 2 dx. So now that makes sense in terms of doing my substitution. So I have an integral 1/6 out front, all right, of u to the 1/2 power du. I'm going to get new limits of integration, right? Take your original limits of integration, plug it into where it says x, where you wrote u. So I'll do that math right up here. So we'll have 3 times 1 squared plus 12 times 1 plus 1. So that's going to be 3 plus 12 is 15 plus 1 is 16. And then I do the other one is 0. Probably don't need to show the work here, but I'll just plug it in, and you get 1. All right. The integral of u to the 1/2 power is going to be u to the 3/2 power, but you need to put that reciprocal in front. And I'm evaluating this at 16 and 1. Don't forget about the 1/6 at the end. It's going to come down here at the end. So I have 1/6 times 2/3 times 16 to the 3/2 power minus 2/3 times 1 to the 3/2 power. All right. Again, you can go to Desmos, feel free to, but I'm just going to do this mentally. The square root of 16 is 4. 4 cubed is 64. 64 times 2 is 128 over 3 minus 1 to the 3/2 power is just 1. So that's minus 2/3. So this is 1/6 times 126 over 3. If you look across, you can simplify 126 divided by 6 is going to be 21 divided by 3, and you know 21 divided by 3 is 7. So 38 is C. Let's do 39. All right, another u substitution here, but something interesting is going to happen at the end. So u equals x squared minus 4. So du is going to be 2x dx. Now you'll notice I don't have 2x dx, I just have x dx. So I got to get that 2 out of the way by dividing everything by 2. This is now, I think, the third or fourth time we've done this. So our 1/2 du is the same as x dx. Okay, so here comes my substitution here. So I have, that's going to be, let's write this as 1/2 out front, and then this is du over u. All right, now I'm going to rewrite that as u to the negative first power du, and this is where I'm going to go to the formula sheet, because when you try to do the power rule here, right, I've always told you to add 1 to find the antiderivative power, but negative 1 plus 1 is going to be 0. So this is a special case, and I'll go to the formula sheet, and this is actually right here, integration formulas involving logarithmic functions. The integral of x to the negative first power is the natural log of the absolute value of x. So since this just says u, the antiderivative is going to be, make that a u there, is going to be natural log of the absolute value of u. Okay? Now, I have that 1/2 in front, so that's going to come down, and I'm going to replace my u with x squared minus 4. So this is what I'm looking for my answer. So that looks like it's going to be C. Okay, 40. All right, another one of these that you'll see ends up needing that formula, same what we just talked about, but u equals 1 plus e to the power of x. Distribute, I should say differentiate, and you get e to the power of x dx, and you'll notice we have that right in the numerator and to the side. So just like before, this is going to be du over u. Rewrite that, and you get u to the negative first power du, which I just told you was the natural log of the absolute value of u. So replace u with 1 plus e to the x, And then when you look in there, you probably might see that it doesn't have the absolute value anymore. That's because your e to the power of x is always going to be positive. All right, like there's no way to get a negative there. So actually, you don't need the absolute value. So even though it looks a little bit different, that's why B is the answer for 40. Okay, 41, almost there. A few more to go. Another u substitution. So I'm going to use u equals x to the fourth power plus 2x squared plus 9. Du is 4x cubed plus 4x. All right, and all of that times dx. Now, when you look in the problem, I see x cubed plus x, not 4x cubed plus 4x, and I do see the dx. So I need to get that 4 out of there by doing the same thing. That's probably the fifth time now. We're dividing everything by 4, but you know I'm going to write 1/4 in front of du, and then that's x cubed plus x dx. So now I'm ready to substitute and do my integration. So I'm going to have u to the 1/2 power du. Let's get new limits of integration. Take these two and plug them into where it says x here. I'm going to do it mentally. 1 to the 4th power is 1. 1 to the 2nd power is 1. 2 times 1 is 2. 1 plus 2 is 3. 3 plus 9 is 12. Plugging in 0 and you get 9. So let's find our antiderivative. Oh, I forgot. Excuse me. Don't forget to put the 1/4 in front here, out front. F of u is going to be u to the 3/2 power and 2/3 to cancel it out to make 1. All right, and I'm evaluating this at 12 and 9. Now, you'll notice the answer choices have some radicals in it, so just be careful here. I'm going to do it by hand, but if you go to decimals, you'll get a decimal, and then just make sure you type in C and D to see which one it's going to be. All right, obviously A and B, you can get those decimals pretty easily. So I'm going to do 1/4 times 2/3 times 12 to the 3/2 power minus 2/3 times 9 to the 3/2 power. All right, so watch what happens with this first one. All right, so that's going to be the square root of 12 cubed. The square root of 12 cubed. So watch how I write that. The square root of 12 cubed, okay? Minus the square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 is 18. So that one was a little bit simpler. Now, from your days in algebra world, right, when you have the square root of some radicand raised to a power, I actually can break this up, and maybe to help to see like what my brain is thinking here. I'm going to break this up into 12 times 12 times 12, and when you repeat two of them, that's going to give me a 12 out front, but still leave me a 12 inside the square root. Okay, so I'm going to keep going this way. So still 1/4 times, so that's going to be 12 times 2 is 24, divided by 3 is 8. All right, times the square root of 12, getting closer, minus 18. All right, now I can actually simplify the square root of 12 to be, there's a 4 times 3 in there, so 8 times 2 times the square root of 3. So we're so close. So I have 1/4 times 16 square roots of 3 minus 18. Distribute the 1/4, and you get 4 square roots of 3 minus 18/4. So that's the answer. If you reduce 18/4 into 9/2, you'll see the answer choice is C. All right, so a lot going on there. Again, go to Desmos to type this in, and then just see which of your 4 answer choices matches. All right, so 41 is C. 2 more. 42, another u substitution. 4x to the 5th power plus 15x plus 2 is u. Take the derivative. 5x to the 4th power. Oh, that's not it. 20x to the 4th power. Sorry about that. Plus 15 times dx. When you look up here, you'll notice that it says 4x to the 4th power plus 3 dx. So I have too much in there. Looks like I've got to divide out by 5. So divide everything by 5. You remember how I'm going to write that. As 1/5 du is the same as 4x to the 4th power plus 3 dx. All right, so now I'm ready to do my substitution. That's going to be du over u, and then put that 1/5 out front. Just like before, when I rewrite this as u to the negative 1st power du, I'm using my formula sheet to know that the integral of my any variable to the negative 1st power is going to give me that natural log of the absolute value of it. Hold on We're not responding for a moment. Let's see what's happening here. I'm going to close it out and pause for a second. Okay, let me pick it back up there. Sorry about that. So it's u to the negative first power du. Again, I know from my formula sheet that this is going to be 1/5 times the natural log of the absolute value of u. Plugging my u back in, I get natural log of the absolute value of 4x to the 5th power plus 15x plus 2. All right, and then you're going to obviously have that plus c. So I'm looking for my answer choice here. So it looks like it is C. Last one. All right, now this one I actually, because it has that x in the bottom, you can actually use u substitution here. But what I did was I actually just did the division first. So I'll do it this way, and then maybe in class I'll do it the other way. So I did this x squared divided by x is x, and then minus 1 over x. And then I split that up into two integrals of x dx minus the integral of, let's write this as x to the negative first power dx. Okay, so then this is going to be, let's see, 1/2 x squared evaluated at e and 1 minus, then this is going to be the natural log of the absolute value of x evaluated at e and 1. All right, so here we go. 1/2 times e squared minus 1/2 times 1 squared. All of that minus the natural log of the absolute value of e minus the natural log of the absolute value of 1. Okay, so this is e squared over 2, and then that's going to be minus 1/2 minus the natural log of the absolute, well, first off, absolute value of e is just going to be e. So the natural log of e is actually just 1. And then the natural log of 1 is going to be 0. So this is e squared over 2 minus 1/2 minus 1. So do your last little algebra bit, and you get that is minus 3/2. Okay, so my answer is going to be E. All right, that's it, guys. That's the whole review. Hopefully you've had a chance to watch all these videos, and good luck on the test.